Good afternoon, Nana, everyone. Yeah, good afternoon. Good afternoon. Uh, Yesterday, I think we were in in the chapter of friction. I think doing some applications. Am I right? Like pseudo acceleration is there, and one block is placed on the open truck. How much time it takes to fall down one model? Am I right? That one completed. And a body, yes, and a body is just like in bowling game, is thrown with certain velocity on a friction surface. Yeah, what is the distance traveled? Good afternoon, Anna. What is the distance traveled and what is the time taken? Good afternoon. I think you already posted that the time taken I left to you to solve. They put the answer t is equals to 5 seconds. Is it correct? Yeah, yeah. Is it correct? Now all of you got the same answer. 5 seconds. Time to stop. Yes, yes, yes. Okay, good. If you got the t is equal to 5 seconds, then your answer is correct. Yes. So two models here. How you get the deceleration due to friction? That is the concept. Okay. The deceleration due to the friction. Okay. And the pseudo acceleration, how it accelerates the body. Two models we discussed. Right then, here, suppose while solving the questions related to this chapter, suppose if you come to like application 3, okay, that one yesterday only I told. I'm telling like along with examples, Nana, every application, so that you can understand very easily if I say the example also. That's why I'm going with examples, all the applications. So here coming to next application. Yeah, in this application, what I'm saying, suppose here, this is one inclined plane. And here, the angle of inclination, say theta equals to 30 degrees I'm taking. And here a block is placed on the inclined plane, okay, almost at the top. Better I say from the point A, okay, and released freely. Okay, this is released. Means it is trying to slide down like this. It is the motion, direction of motion. Okay, and he said that either directly the length of inclined plane or indirectly height of the inclined plane. Anyone suppose given. Okay, suppose height is given as say some 10 meters. Then what is the length of inclined plane? According to mathematics, you can calculate it using the right angle triangle concept. The length is nothing but sine theta is equal to h by the length of inclined plane. You take it as suppose L. That one you can calculate. Am I right, Nana? This is L. Okay. Good. Right. Here, Suppose directly L or H, anyone given. In this problem, I took H now. Okay, so that you can calculate L. Question is, suppose the bottom I take it as B to reach from A to B, dropped freely, Nana. U equals to 0 here. That you don't forget. U equals to 0 there. A to B, the time taken on this AB is smooth. On smooth surface, is T1, and that on rough surface of mu is equal to, say, some 0.2 mu, I take it as better 1 by root 3. Yeah. I take it as 1 by root 3. Okay, mu is equals to 1 by root 3. Better I take 1 by 2 root 3. Okay, this is the value, Nana. Mu, rough surface. On rough surface is T2. Then the relation between T1 and T2 is, okay, this is the question, right? Here, how to solve? First, you understood, I think, the question, what he asked. First, you consider A to B as smooth and the body is sliding down. What is the time taken to reach the bottom B? That whatever you calculated is T1. Next, consider the same surface as rough with mu value 1 by 2 root 3. Again, to come to slide down to the point B, the time taken, you calculate. That one, how much you get there, you consider it as T2. Then T1 and T2 are related as. That is the question. Now I explain the question, Nana. All of you understood the question first? Okay. If you understood the question, then it is very easy to start. Yes. Okay. Right. Good. So we can start the problem now. Okay. So here it is started from rest. First, what I am taking here, the surface is smooth. So obviously, what I have to take on smooth inclined surface, already you know the acceleration equals to, I will check how many remember this one. What is the acceleration on the smooth inclined surface, Nano? Oh, okay, maybe. First answer to my question, Mr. Manikanta, acceleration is how much on the smooth inclined surface? You already posted the time, means you already calculated. What is the acceleration? Yeah, good, good. That is F by M, correct, Nana. F how much, Lakshmi Gayatri? I think it is not so, Deepali, and my voice is not breaking. If my voice is breaking, how they answer to my questions? They are answering. Means I think my voice is not breaking. Yeah. No, 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 no. Why? Because they are saying they're responding. It is not breaking. Ah, okay, Lakshmi Gayatri, correct, correct, okay. But here what I'm asking, yeah, how much? Correct, enough. Formula I'm asking, not the value. Manikanda, you are right, you are right. Others I'm asking. The force on the smooth surface is mg sine theta, Nana. F by m correct, Nana. F how much? That's what I'm saying. Mg sine theta, that we have to say, na. So mg sine theta by m. So try to remember A is equals to G sine theta. Right, right. G sine theta. Okay. If you remember like a formula, you can use in other questions. Acceleration of smooth inclined plane is G sine theta. Okay, we can remember as a shortcut. Okay. When you come to this problem, you can substitute. Okay. Later we substitute. First we are coming to the concept now. Okay. Actually, this is concept, not solution. Okay. So here coming to the concept, I got the acceleration, and here the distance A to B is L. Okay. In the problem, of course, I will calculate it. Okay, right, right, right. First, all of you are trying to calculate the value, Nana, but I am trying to calculate the formula related to it. Means I'm trying to say the formula related to it. Okay, not the answer. Okay, and u equals to 0, and time he has given that as t1. So from all these informations, I'm going to use s is equals to ut plus half at square here. So without substituting the values, I'm trying to find out one formula here. Yes, yes, I'm trying to find out one formula here. Will you get such type of formula, Nana? Okay, maybe. S is equals to L. L is equals to U0, U2 0, half A is G sine theta into T1 square. This is the first one. Okay, T1 you are saying. Right, right, right. That implies T1 is equals to, yes, you can take it as 2L divided by G sine theta. This is T1 square. So T1 is equals to root of 2L by G sine theta. Okay. First, I derived one formula here. This is a formula. Okay. Later, I come back to the question. I try to substitute the numericals. Okay. Over. Then I am going to T2 here. T2 means what will be the acceleration on rough surface here if I consider the surface is rough. No, no, not m cos theta, Nana. I think yesterday or day before I told the acceleration on rough surface is equals to g into sine theta minus mu k cos theta. If I'm not wrong, is it correct? Acceleration on rough inclined surface. Yes. I think you are trying to recollect now. This one already I gave Nana on the rough inclined surface. Okay. You know the acceleration even on the rough surface also he said A to B, that is L. But the time taken he gave it as T2. Okay. But started from again rest U equals to 0. Means same thing again. S is equals to ut plus half at square. Again, I am not trying to substitute the values here. Just I put L over here. Ut is 0. Half A is G into sine theta minus mu k cos theta into T2 square. From this, I can find out T2 is equals to in the same way 2L cross multiplication whole divided by G into S sine theta minus mu k cos theta. Okay, this is T2 square again under root. So in this concept, just I gave two shortcut formulas to you. Yeah, what is the time taken to reach the bottom on smooth, and what is the time taken to reach the bottom on rough, provided it is started from rest. Okay, this is the concept for that. Now I am going back to, oh, Amol got one answer here. Okay. Right, I will check it, Nana, whether your answer is correct or wrong. Now I am going to find out as usual what is T2, what is T1. Okay, before starting that one, I have to find out L value from the triangle. Okay, so from the figure here, now I am going to the solution. Okay, here I am writing from the figure. Sine 30 is equals to opposite side by hypotenuse, h by L. H is given as 10. So here I write sine 30 is half is equals to 10 divided by L. So I got L is equals to 20 meters. Okay, my calculation I got here. And without deriving anything from the concept, I go to the shortcut. Okay, T1 is equals to root of 2L by, 2L by G sine theta. Here I write. And straight away I substitute all the values here. Root of 2, L is 20. Oh, sorry. L is 20 divided by G is 10. Sine 30 is half. Okay. So here cancel. I am getting this is root 8. That is equals to 2 root 2. Okay. I think few already posted T1 is equals to 2 root 2. Few students posted. Yeah. Who posted? I did not see anyone here. Okay, Manikanta got right. Okay, right. Lakshmi Satvika. Okay, right. Then here T2, I am going to calculate again using my shortcut 2L by, according to my formula, G into sine theta minus mu k cos theta. Okay. This is again root of 2 into L. Okay. L is how much? 20. 2L by G is 10. Sine theta. Sine 30 is half. How much is the mu k value? 1 by 2 root 3. Okay. 1 by 2 root 3 into cos 30. Cos 30 is root 3 by 2. Okay. So root 3 cancel. I am getting the numerator root of 40 divided by 10 into half minus 1 by 4. That I will get here. This is root of 4 by half minus 1 by 4 is 1 by 4, Nana. After taking LCM, 4 minus 2 by 4. That is 1 by 4. Okay. Half minus 1 by 4 is 1 by 4 only. Yeah, 1 by 4. This is equals to root of 16. That implies T2 is equals to, I got 4 seconds. Now I am getting the relation between T1 and T2. Okay. How, sir? Simple. If you divide, you will get the answer. T1 by T2. T1, T2 relation. Yeah. Here, if I divide the two equations, T1 by T2 is equals to 2 root 2 by 4. 2 2s are, this is root 2 by 2. Root 2 times 1 by root 2. Therefore, I got T2 by taking the cross multiplication. T2 is equals to root 2 times 2 T1. This is the final answer. No problem, Nana. Is it correct? Yes. Correct one. Very good. Right. So no calculation mistakes in the middle. Right. Why? Because I think you also got the same answer. Right. The same question, suppose if I ask like this. You observe once my example where it is taking more time on rough or smooth. Once you check here, T2 is greater than T1. T2 is greater than T1 means on the rough. Okay, he is saying that here the time taken by a block, okay, starting from rest at the top of an inclined plane, okay, on inclined plane is, I have to mention on, better I write on a smooth inclined plane is n times where the time taken is more rough. Okay, then I have to say like this. Sorry, I'm changing the question many times here. Kindly excuse me. On the top of a rough inclined plane is n times to that on smooth inclined plane. Thank you, thank you. Smooth inclined plane. Okay, find mu. Coefficient of friction equals to how much? This was previous mains and MSET question, Nana. In both the exams already he gave. Okay, he gave this one already in exam, previous exam question. Then what is the answer for this question? Okay. Here, after knowing the concept, I think it is very easy to say the answer for this question. Why? Because he said on rough. On rough means T2 is n times that on smooth. Smooth is T1. So he gave indirectly whatever we calculated here. Okay. in terms of some n. Okay, means he is asking the question quite in a reverse manner. In the previous problem, he gave mu value and asked the relation between T1 and T2. In this question, he gave the relation between T1 and T2, asking the mu value. Quite contrary. Okay, quite opposite to this question. So very simple, Nana. It's not a big deal. Very simple. Why? Because already you know what is T1, what is T2. Just substitute the two T1 and T2 values here and solve. You are a mathematics student, so you know how to solve the equations from maths. So simple, T2, just without turning the page, I'm substituting here. Yeah. Yes, thank you. Then quickly complete. Substitute and complete. Mu is equals to, yeah, exactly, Amok, you are right. Good. Your answer is correct. Abba, Manibabu, wrong. Once we check Manibabu. No. You are just trying to type some numerical value. How you get the numerical value here? That is n I gave, n times 2 T1. Okay, in the meanwhile, I also try here. T2 root of 2L by G into sine theta minus mu k cos theta is equals to n times 2 T1 without turning the page back. Here I am substituting 2L by G into sine theta. So here under root 2L, under root 2L, under root G cancel. And I'm after cancelling square on both sides. Okay. So already 2L cancelled, G cancelled. I will get 1 by sine theta minus mu k cos theta here is equals to, better I cancel, otherwise you may get some confusion here. 2L cancelled, G cancelled already. Squaring means this becomes n square. Okay, into 1 by, you will get just sine theta there in the second equation here. So cross multiplication, n square. Yeah, now it is correct. Manibabu. Here sine theta equals to cross multiplication n square into sine theta minus mu k cos theta. Simple, n square sine theta taken to the other hand, that you will get sine theta minus n square sine theta is equals to minus n square mu k cos theta. Since I got minus here, I reverse these two terms. That is n square sine theta minus sine theta equals to n square mu k cos theta. That's it. Simple. Sine theta taken out. This becomes n square minus 1. Above example means, there, if n is given as suppose to whatever you get here 2, then you can get that value as here n as root 2 nana. If given n as root 2, then you can say mu is equals to 1 by 2 root 3. But n is not root 2 na. So you can't say straight away. Okay, right. Sine theta is equals to n square mu k cos theta. Therefore, coming to the last step, mu k is equals to taking n square cos theta to the other hand, sine theta into n square minus 1 divided by n square cos theta. Sine theta by cos theta is tan theta into n square minus 1 whole divided by n square equals to mu k. That is r1 minus 1 by n square. Okay, I think n square you missed there, Mr. Manibabu. Even Amog also missed n square term. Yeah. Manibabu and Amog both missed n square. You directly put n. Okay, right. Good. A small correction there. That's it. Then after doing small correction, your answers are correct. So all of you understood this shortcut formula, Nana? Previously given question? Yeah, good. Yeah. Tan theta into 1 minus 1 by n square. Correct, Dornala. You forgot their tan theta. Okay, right, good. Yes, okay, right. This was one question previously given in exam. Okay, so application 3 is over. Okay, this is application 3. Related to it, here we solved in that application only one question and previous question. Okay, so application 3 is over. Yeah, this is correct. Now we are moving to application 4. Okay, coming to here, application 4 means example 4. My point of view. Okay, this time what he is asking, actually in the previous application, on smooth and on rough, in both the cases, we dropped from the top and we studied the motion when it is sliding down. But this time, what he is saying, he is trying to project one body from here, like taken at the bottom. And if you ask to go up, it never goes up unless you give some velocity. Okay. From the top, even without giving the velocity, you simply leave, it may go down, but it won't go up. All of you know that. Okay. Why? Because the component of weight tries to oppose the motion. This is the biggest disadvantage. Mg sine theta acts in this direction. That's why to overcome that component of weight, what I am doing, I am giving some initial velocity like this, like projecting on the inclined surface. This is the initial velocity u along the inclined plane. Okay, length of inclined plane, I am taking it as L. It is the length. Okay, it is the length of inclined plane. Right? Here, suppose it is projected from the bottom A just to reach the top. Just to reach means, keep in mind, final velocity is equals to 0. Okay. If it reaches, find in the given figure after projecting with an initial velocity, find the time taken to reach the top. Okay, We are doing such type of application as a numerical. That's why I'm giving the values here. Theta is equals to, again, you take it as 30 degrees. L is equals to, you take it as 20 meters. And mu, you take it as 1 by 2 root 3. Okay. These are the values. So first, will anybody say here, when I come to the concept, what will be the deceleration of the block while going up? Minus A is equals to how much? Will anybody say deceleration? Consider this as a rough surface, Nana. Keep in mind, not smooth. Check it. Here, anybody will respond or not? What will be the deceleration here of the block? Nana, deceleration means, Ishan, only friction opposes, or else along with the friction, some component weight also. Yeah, now it is correct, Lakshmi Gayatri. But I think we require some correction in our formula. Yeah, Tanisha, correct. Yeah. So, who opposes the motion means not only mg sine theta, when it tries to slide along the inclined plane, immediately the Barudhai force also opposes the motion. You know who is the Barudhai opposing the motion? The waste fellow, friction. Okay. So friction also acts in opposite direction to the motion. So when the block tries to go up, these two forces are pulling its legs backwards, means opposing the motion. That implies, here I'm coming to decelerating force is equals to, decelerating means I have to put minus. Okay, or else, okay, later while substituting m into a, there we write the minus sign. Anyone, that is your wish. Decelerating force, not only mg sine theta, but also f. Both are decelerating. Both are in opposite direction to the motion. So here, by that, the deceleration you will get, that is minus a, equals to, deceleration is decelerating force by mass, F by m. That is mg sine theta plus F. It is the F acting, okay, by m. Okay, that one you are getting mg sine theta plus F while going up, kinetic friction. So kinetic friction, you can write it as mu k into n. N is mg cos theta divided by m. Here, I think you understood, Lakshmi Gayatri, what the small mistake you did there. This is equals to, if I cancel by taking m common at the numerator and denominator, I am getting g also common. Sine theta, I am not getting minus, plus mu k cos theta. This is what I got, the deceleration minus a. Now you understood the mistake, small mistake there. So first of all, the concept all of you understood, Nana. The deceleration, yes, yes. Deceleration here while going up. So I am going to keep it, yes, good. Going to keep it in a box. This is the deceleration. When the block is trying to go up. Right, good, good. If I know the deceleration, already he gave the initial velocity, final velocity, distance, and the deceleration I found here. So V, U, A, and displacement S are related as V square minus U square is equals to 2AS. Okay, no? So here I write from this equation V square minus U square is equal to 2AS. I write in the next page here. Yeah, correct. 0 square minus U square is equals to 2A, that is minus G into sine theta plus mu k cos theta. That is deceleration. That's why I put minus here. Into S is L. Now you understood this one? The step what I substituted, correct or wrong? Yes, correct. So both sides minus get cancelled. I'm going to get here u square. U square is equals to 2GL into sine theta plus mu k cos theta. Okay, this is one formula used if they ask the initial velocity by giving L. Okay, if they ask. But I think for our problem, it is not helpful. Why? Because he is asking the time. Okay, their time. Initial velocity not given, Nana. Keep in mind. Initial velocity is not given. But he gave L here. Okay. And final velocity is given. That equals to 0. L means displacement. S is equals to L. Final velocity is equals to 0. A is equals to, of course, you know, minus of G into sine theta plus mu k cos theta. And he is asking what is the time. What formula is to be used here? I think all of you remembered long back I gave. S is equals to, instead of ut plus half it square, there is one more equation on a vt minus half it square. Remembered this equation? All of you? Yes, yes, yes. Better you go with this equation. Vt minus half it square. Simply you will get the answer. Yeah. Yes, I'm going to substitute here L is equals to Vt happy 0 minus half A. A is again minus plus G into sine theta plus mu k cos theta into T square. In the same way, take the cross multiplication 2L and throw this whole term to the denominator by G into sine theta plus mu k cos theta is equals to, you will get T square. So T is equals to root over. Okay, Nana? If there is any mistake, you can tell now. Otherwise, accept my equation. Any mistake is there, Nana, in my equation? No, no mistake. Okay, thank God. Now keenly observe. Here, this is the time taken by the body to reach the top. And it is the time taken by the body to reach the bottom. Which one? This one. Okay. Difference you observe on the rough surface to come down. Just only one difference you are finding out here. While coming down from the top to bottom on the rough surface, you got minus. Yes, here minus. Same equation we got in the fourth page with the plus. This is while going up, that is while going down. Okay. So here come to your problem solution. Here. Okay. Come to the solution, quickly substitute. Already it is 350. T is equals to root of 2L, I think given 20 in my problem. G is 10 into sine 30 is half plus mu is 1 by 2 root 3 into cos 30 is root 3 by 2. Okay. So 0, 0 cancel. I'm getting root 4 here. Root 3 cancel. I will get half plus 1 by 4. That I will get here. T is equals to root over 4 by half plus 1 by 4 is 5 by 4, if I am not wrong. Okay. Then here this is root of 4. 4s are 16 by 5. So I am getting the answer T is equals to 4 by root 5 seconds. Okay. So all of you understood this question, Nana? Yeah, good. So almost I'm going to wind up by leaving one question to you all. Okay. 3 by 4. Not 3 by 4. I think it is 4 by root 5 only, Nana. Amok. Oh, sorry. Half plus 1 by 4 is 3 by 4. Hey, yeah, super, Nana. You are super. Yeah, it's my mistake only. Good, 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 good. Mr. Amok. Half plus 1 by 4. This is actually 3 by 4, Nana. Okay, all are, I think, in hurry. That's why no one identified the mistake. Only Amog identified. Okay, good. This is 4 by root 3. Okay, good, good. Yeah. Now I'm leaving one question to you all. Try to solve this one by Monday. Okay, right? A block is sliding on a rough inclined plane. Okay, first from top to bottom. Okay. No. You try to solve it tomorrow. Means Monday. You tell the answer. First from top to top to from top to what is this nonsense? From top to bottom. Okay, and then from bottom to top. Okay, the respective times are T1 and T2. They are related as T1 is equals to NT2. Then mu k equals to. This is the question. Okay, I think all of you can solve very easily. This is T2 value. Already I solved here. Formula I gave in this box. And this is while going up. And here T1 already I gave in this box. This is T1. So T1 is equals to N times 2 this T2. Equate those two. Okay. N times 2 T2. Square on both sides and solve. Okay, good. Solve it now. So shall I stop the class now? Oh, Nana, this is N times, not a numerical value. You will get one formula like this, like a tan theta into n square minus 1 by n square. Now, like this, you will get the answer. Okay, that answer I require. Yeah. Bye, Nana. Bye, everyone. Do you want the pages? Yeah, right. Thank you. Yeah. Thank you, Nana. Thank you. Right. No, Dipal. All right, there is no fifth page. Sorry. Okay, Nan. Bye, everyone.